Hello and welcome to the section 10.2 lecture today. Today we're going to be talking about multiplying polynomials. To take a quick look at how to multiply polynomials, let's look at a little picture. So this following rectangle has a width of x plus 2 and a height of 2x plus 1. So this is x, this is 1, so x plus 2, 2x's plus 1 here. So I want to find the area of each of these parts, each rectangle or square that I have. Area is length times width. So x times x is x squared. The green ones, so this is another blue one that has the same area. The green ones, x times 1 is x. X times 1 is x. Same thing on these two. They're both x's. This one is 1 times x, so it's still x. And then these yellow pieces are 1 times 1, which is 1, 1 times 1, which is 1. To find the total area of this, we want to add up each part. X squareds, I have 2x squareds. Excuse me. 1, 2, 3, 4, 5 x's, and plus 2. So when we multiply polynomials, we can think of it in this layout that, how can I piece these together and make things work out? Obviously, we're kind of assuming the size of x here, but it doesn't really matter. Okay, we're just considering it some decent sized shape. Okay. There's multiple forms of multiplying polynomials. A monomial times a polynomial, well, you've done this before. It's just distributive property. I want to multiply a by everything in those parentheses. A times b plus a times c. And that's the main thing that we're going to look at today. Tomorrow we're going to look at some more difficult polynomials to multiply. All right, but we do have a little bit of an elevated issue that we're dealing with on this one, and that is that we have our the thing outside isn't just a number. Okay, it's almost better if it has a variable itself. And we haven't really dealt with this yet, but that's okay. If I think about taking 3x times 2x, that's just going to be the two numbers multiplied together. 3 times 2 is 6. And x times x is actually x squared. So whenever I'm multiplying variables together, it doesn't add another number to the number, it's adding to the exponent. So we're going to have 6x squared. 3 times 5 is 15. And there's an x involved with that. On the next one, I'm taking a 4x, distributing it to x squared and 3x. If I write this out, it's 4x times x squared plus 4x times 3x. And we talked about this kind of a side here. Oops, plus sign. 4 times 3 is 12, and x times x is x squared. If that's the case, what do you think this is going to give me? It's going to give me 4x cubed. Okay. The next one that we have is going to distribute a negative 2x squared. And so this is going to be negative 2x squared times 2x cubed minus negative 2x squared times 4x. So we're going to continually add to this multiplying x's conversation. Negative 2 times 2 is negative 4. X to the second power times x to the third power is going to take us to x to the fifth power. This one I'm going to have negative 2, so I'm just going to switch that to a positive. 2 times 4 is 8. X squared times x is x cubed. Okay. Kind of getting ahead of ourselves with our exponent rules here, but that's okay. This one, distributing a 1/2, or negative 1/2 x to the fourth. Negative 1/2 times 6 is 3. X to the fourth times x will be x to the fifth. Negative 1/2 times negative 18 will be positive 9. And there's an x to the fourth there. So take today for what it is. If it's easy, make it easy. Focus a little bit on what happens with the variables that are going in there. But this is just distributive property. Put any questions you have over on the left. Otherwise, I hope you have a great day, and we will see you in class.